Good day. In this video, I will be demonstrating how to properly plot and determine the target details using maneuvering board. So, in this scenario, you are the OOW on board MBCEC course 025 degrees through with a speed of 12 knots. You observe a target on your radar at 1200 bearing 045 degrees through with 9 nautical miles range, and at 12:06 the same target bore 0.45 degrees true and 6.5 nautical miles. So first we write the given. So this is our own ship data. Course is 0.25 degrees and speed is 12 knots. And the target data, the R and M, so time, bearing, and range, the here and here. Then we plot it. So how to plot it? So first, we measure 9 nautical miles. We measure 0.5 degrees 0.5 degrees and then 9 nautical miles from from the ship, from the ship center to here. So this is 9 nautical miles. And then we label it as the R, and then and at 12:06 we measure the 6 nautical miles 6.5 nautical miles in the same bearing, which is 0.45 degrees. So we label it M, and then we draw a line, and then we call it RML or relative motion line. So that so and then we determine that we will write the E. We draw a line from your ship's course, which is the 0 to 5 degrees through here, the ship 0 to 5 degrees through and 12 knots. So we draw a line 0 from E to R is 0 to 5 degrees through. Then to determine what will be the distance of this, we use the nomogram, 1.2 nautical mile, 12 knots in 6 minutes. 6 minutes. So this is 12 knots, then 6 minutes here. So we draw a line here to determine the distance in nautical miles. So that is 1.2 nautical miles. So we measured 1.2 nautical miles from the R to the E. So this is 1.2 nautical miles. And then we connect it. Then we will connect it the E to M to determine the target true course, which will come later. So I will explain. So first we will to we'll find the relative speed of the target. So to find the relative speed of the target, we will measure from R to M. So this is 1 to 2.5. So 2.5, and we'll use the nomogram also. So this 2.5 distance is 2.5, and the time is also 6 minutes. So we draw a line here, and using this ruler. So 1.5, and then so we 2.5, and then we determine that we found out that is 25 knots. So the relative speed of the target is 25 knots here. And then to find the CPA and M to CPA, we will make sure the here. So here, so M to CPA is 6.5 nautical miles, and then the CPA, or closest point of approach, is 0 nautical miles, because the CPA is measured from the vessel to perpendicular from the RML perpendicular to the vessel, the line here from RML to the vessel. So here it's nautical mile. Since the RML intersects with and the center of the compass rose, this plus symbol or cross symbol, so it is 0 nautical miles. We wrote it here. The CPA is 0.0 nautical miles, and the M to CPA is 6.5 nautical miles. And then we'll find a TCPA and a BCPA. So TCPA, to find the TCPA is we will use the nomogram also. So the given is 6.5 nautical miles, 6.5 nautical miles, and then the speed is 25 knots. So we draw a line here, so that is 16 minutes. Then here from M to the CPA is 16 minutes, so we add the time for M by 16 minutes, so 12:06 plus 16 minutes is 12:22 hours. So we wrote it here. And then the BCPA is 0.45 degrees true. And then the next is TCC and TTS. So determine the TTC. So TCC is measured from the E to M on bearing. So we drag this we will drag this line to here. We use a triangle, then we come up with 242 degrees true. And then to determine the speed of the target, true speed is we measure the from E to M, the distance between E to M. So using the using this compass divider, we will we have determined the distance of this. So the distance of that is 1.5 nautical miles. So 1.5 nautical miles, and then we are about to find the speed. So the given is 1.5. We also use the nomogram, so 1.5 here, this line 1.5, and then 6 minutes also. So we draw a line there, then we come up with 15 knots. So wrote 15 knots. Then to determine the target aspect, so target aspect is measured from the heading of the target, or from the heading of the target through the to the to your ship, the bearing of from the target to your ship, bearing of that. So since the target through course is 242. Oh, the formula for target aspect is target through course. Target through course subtracted by the bearing of the M, bearing of the M, then subtracted by 180. So we subtracted 242 degrees true minus 055 degrees true minus 180 degrees true. So we have determined that it is 17 degrees. And then the R in 17 degrees is the color that we see and during the night. So just imagine it's night time. So this is your this is the target, the course of the target, and then this is you, and then when you saw the target, you only see red because the you are in the port side of the target. So that's it. So the situation is crossing situation. Then yours your action to avoid collision is always based on Colregs. So Colregs rule number 15, crossing situation. Initial action. I am the giveaway vessel as per Colreg rule number 15. As per rule number 16, action by giveaway vessel. So I am the giveaway vessel, since you have the vessel on your starboard side. You have the target on your starboard side. So as per so as per rule 16, action by giveaway vessel, I will take early and substantial action by keeping clear of the stand-on vessel and avoid crossing ahead of the other vessel by altering my course to starboard, also in accordance to rule number 8, action to avoid collision. So that's all. I hope you enjoy, and I hope you learn in my demonstration. So thank you and goodbye.